In Activity 1, the investigation question is, how will a changing net force affect the acceleration of a cart when the system mass is constant? This lab involves the study of Newton's second law. We already know that Newton's second law is net force equals mass times acceleration. For this experiment, we can isolate A to get acceleration equals net force divided by mass. By increasing the net force, the resulting acceleration should increase, since net force is in the numerator. Therefore, our claim is that by increasing the net force, the cart's acceleration should increase as well. We hope that this experiment will provide us a better understanding of Newton's second law.
We now move on to the method. In the slide shown, we have laid out our lab setup. The materials used in this experiment are the following: weights, a track, a cart, a motion sensor, and a Chromebook. The independent variable, which is the pulley mass, was measured by our eyes since we had to ensure that the system added up to 500 grams. Moving on to the dependent variable, which is acceleration, was measured by the motion sensor. Other variables were controlled by the blue foam at the end of the track. The independent variable was changed by switching out the masses and making sure that the total system mass stayed at a constant 500 grams. Because changing out the mass did not require a tool except for our eyes, there were no need for a tool except for our hands and vision, ensuring that the system mass stays at 500 grams. The dependent variable was changed by adding or removing masses. The tool used to measure the dependent variable were the motion sensor and the Chromebook, allowing us to measure the cart's acceleration. This experiment must be controlled through the release of the cart without adding additional force, the foam stopping the cart at the end of the track, and beginning and ending the motion tracker accurately. A procedure is the following. 1. Set up the track, cart, motion sensor, and pulley system, ensuring that the track is on a flat surface above the ground and that a string with a loop attached to the cart is hanging at the end of the pulley system. 2. Choose weights that add up to 500 grams and add them to the cart and to the end of the string. 3. Position cart and weight in correct spots. 4. Release weight and begin the motion sensor. 5. End recording when cart comes to a complete stop. 6. Use the data recorded from the motion sensor and put it into a velocity versus time graph in order to find the slope, specifying the cart's acceleration. 7. Repeat steps 2 to 6 3 times to find acceleration for a total of 3 times and find the average acceleration. 8. Change the combination of weights and repeat steps 2 to 7 while ensuring that the total system mass stays at a constant 500 grams. As shown through these videos, we see our procedure take place. In the first video, we start the sensor at the same time the cart begins to roll. Here, the cart comes to a complete stop and our motion sensor is ended. In this video, you see our procedure take place and us repeating it multiple times by ensuring that the cart and the pulley mass is in the same position at all times, keeping the cart straight and the pulley mass from dropping.
For this lab, our claim was that by changing the mass of the system through taking mass out of the cart and putting it into the pulley would indeed increase the cart's overall acceleration. Our data supports this claim, since as more mass was added into the pulley and taken out of the cart, the acceleration did in fact increase. Thus, there's a positive correlation between the amount of mass in the pulley and the acceleration. If we would put more mass into the pulley, the acceleration would increase. The problem that we faced during our procedure was the error in the data tracker. Due to the constantly fidgeting animated objects in our classroom, such as humans, our data tracker lost focus of the cart, thus miscalculating the acceleration of the cart. This is shown since of the 3 trials, they were all different. None of them were the same. For future investigations, I would suggest doing this trial in an enclosed environment, in which stillness is attained. Thus, the estimates of the data tracker would be more accurate.